Reading. Yes.
Do you mean on the reading we just read for chapter 2?
Yes.
Okay. Do you want us to follow the, what do they call them, the capitalization of the first letter for the classes, or what do they call it, something with a C?
Conventions. Conventions are good. Some languages have conventions that are all over the place. Some groups of people use one convention, some groups of people use another convention. So in those cases, it really doesn't matter what convention you use. Java has a very specific set of conventions. So some of the ones that I can think of off the top of my head are class names always start with a capital letter, and every word in the name, even if it's a preposition or an article, is capitalized.
At the beginning of each new word, correct?
Beginning of each new word. No underscores, certainly no spaces. All crammed together. Class names start with a capital letter. Everything else, every other identifier starts with a lowercase letter. It follows something called camel case, whereas class names follow title case. Camel case is called camel case because it has uppercase letters in the middle that look like humps.
Okay.
There's no dromedary case or anything like that. So class names are title case, variable names are camel case. Method names, we haven't talked about methods yet, but, well, we've mentioned methods. We haven't discussed them in detail. But when we get to naming methods, methods also get camel case.
Okay.
Named constants, the convention is all capital letters with underscores between the words.
What is that?
Named constants.
Named.
If we haven't talked about them already, we'll talk about them eventually. I think those are pretty much all the identifiers. Another convention that doesn't particularly pertain to the case that's used, but frequently, if you only create one instance of an object, so the new scanner line that we've been using, the book uses scanner keyboard equals new scanner. A lot of times, if there's only one instance of a particular type of object, it's named the same name as the object, just lowercase, or camel cased, depending.
So what do you mean by that? I got a little bit confused. So like scanner keyboard, new scanner, you're saying that the second scanner would be lowercase?
Instead of calling it keyboard, a lot of people will call it scanner, just lowercase.
Scanner instead of scanner keyboard?
Yeah, it does get a little odd to read, but I didn't make the conventions. I also don't usually follow them. The other convention that I can think of is where your curly braces go. I am very used to a C convention because I started writing C, which puts the curly brace on the next line. Java's convention is to have the curly brace on the same line, separated by a space. I find the curly brace on the next line easier to read, but Java convention is to have the curly brace on the same line. I'll try to stick to that, but I can't make any promises. It completely syntactically equivalent.
So can we do it the other line than another one? Is that okay?
I probably won't notice that you did it differently, honestly. But it's probably a good habit to learn the Java convention. Usually after typing a program, I will catch where I break convention and fix that so that when we talk about line numbers and if I post any of the programs I write, they should follow the conventions. But again, they're just conventions. They're guidelines more than actual rules. Someone got that reference. Alright, so today we'll talk about variables and strings and expressions. So I think I mentioned last class that computers, all they do is really add numbers. Even though all they do is add numbers, they also have other various operations, multiplication, division, and we saw some of those. Some of those are in the assignment, and I think one of those is actually in the code listing that's provided in the assignment, multiplication. Most of that is multiplying individual numbers. The example that's given is multiply 6 times 3. That's an expression hard-coded right into Java code. But sometimes we don't want to have a single value always be multiplied by a single other value. We want to have some options there. And that's where variables come into play. They're basically buckets that we can store values in. And like different types of things in the real world, variables have different types as well. And we've already seen one of those in the program we looked at on Monday. Which would be this one. So here we're doing some addition, and this right here is a variable. It has a type and it has an identifier. The type describes what form of data it can hold, and the identifier gives it a name so that it's easier for us to deal with. Another bad habit I have, and so all of these bad habits, my business partner claims that he has none of them and gets really frustrated with me when I continue to exhibit these bad habits. Another bad habit that I have is single letter variable names. And the excuse I give for that is that if you have more than 26 variables in a method, it's doing too much. The reality of that is that I'm just lazy. If what I'm describing starts with an A, I name the variable A. If something I'm describing starts with a Z, I name the variable Z. His counter to that argument is that the only place you should ever have variables named A, B, and C is if you're computing the quadratic formula. So there are certain cases where convention dictates single letter variable names, which we'll see in later lectures. But here we have two variables, two different identifiers, N1 and N2. We can't create two variables with the same name because that would be ambiguous, and that results in Java exploding on us when we try to compile it. Some of you saw that in doing the assignment with the scanner. If you try to create another scanner keyboard, it says you can't do that. You've already done that once. So in Java, we have a few different types. And they fall into two groups, primitive types and class types. Class types are a pretty big topic that we'll deal with in more depth later. But for now, they operate essentially like primitive types. So we created a variable of type scanner called keyboard. Scanner is technically a class type, but it works the same way as any other variable. The primitive types are more or less atomic. They store a value that is a single value. It can take up a fixed amount of space. And that's really a holdover from C, where in C you have to manage your own memory, and something that has a fixed amount of memory is a primitive type. In Java, it's the same way, but we don't actually see any of this memory stuff.
So float would be a class type.
Float is a primitive type. It's kind of weird how that works, but floats and doubles do take up a fixed amount of memory. And that's something that you'll learn in
Well, here it just
2160.
takes up a single number. So a primitive type is a set amount of memory then?
Yes. So things like int, float, double, long. I should probably make sure I mention all of the ones the book does and probably not too many more. So it mentions byte, short, int, long, float, double, char, and boolean. Some people pronounce char char because they look at the way the letters are spelled and pronounce it like that. As far as I'm concerned, char is a fish, and char is a shortening of character. So I will call it char. And all of these primitive types do take a fixed amount of space, and depending on how much space they take up, they can store different types of data. A byte, and that's the third column, the memory used. Byte takes up 1 byte of memory, which is 8 bits. A nibble is 4 bits. That's spelled with a Y. And can store numbers from -128 to 127. It's signed. In Java, there aren't any unsigned types. So everything has either is either a positive or a negative, or 0. Short is twice as long. Int is twice as long as short, and long is twice as long as int. So if you're storing really big integer numbers, long is the appropriate type. But for most things that are integer types, an int, which I might accidentally refer to as integer, different programming languages either call it int or integer. They're all representing the exact same type. That's sufficient for most applications, and you can see the range on that is pretty big. -2 billion something to 2 billion something. That should be sufficient. For things that have fractional components, we have 2 types, float and double. In most languages, the convention is to use float because it's big enough. In Java, the convention is to use double for everything that has a fractional component. So in this class, whenever we need something that will use a fractional component, I'll use a double. A lot of the constants that have fractional components, like e and pi, which are actually available somewhere in the Java framework, those are doubles. Char data type stores a single character. In Java uses a mapping from characters to numbers. Again, computers only deal with numbers. That represents each character with 2 bytes. This is sometimes called Unicode, though Unicode refers to a family of character mappings. The one that Java actually uses is UTF-16, basically meaning 16 bits to represent a character. And a Boolean, it says memory used 1 bit. I don't think that's actually accurate, but you can pretend that's the way it is. Because a Boolean only has 2 states. It's either true or false. And those are the only primitive types in Java. So pretty much everything else is a class type. And when it comes to types, a good way to differentiate between primitive types and class types is primitive types, the name of the type, int, long, always starts with a lowercase letter. Class types always start with a capital letter. Again, that's convention for the class types, but
So
most people don't break that.
Class types show you.
Right. So Dr. Java is very simple. Takes a very simple approach to this. If the type starts with a capital letter, it colors it blue and says it's a class type. So if I changed this to a lowercase s, aside from not compiling, Dr. Java won't recognize it as a class type. And even though, so let's say I want to pretend there's another type that doesn't exist, and I'll call it something like that. That doesn't exist. Dr. Java has no idea if there's a class type called scanning, but it starts with a capital letter, so it's going to color it blue. So don't assume that just because Dr. Java colored it blue, it is what you intend it to be. It is a very simplistic approach. If it starts with a capital letter, it colors it blue. So there's also a distinction. We haven't talked about strings yet because they're actually class types. But if we want to store create a variable called the letter A and we want to store the letter A in it, if we do that, which is what would kind of make sense based on what we've seen so far, this will actually not compile. And the reason for that, it might actually give a reason. Let's see how cryptic it is. Yes. Found, string, required, char. Anything in double quotes is a string. Doesn't matter how many characters are in there. Anything in double quotes is a string. In order to make it a character, we surround it by single quotes. And these are what are called literals. A character surrounded by single quotes is a character literal. It's a hard-coded character right in the code. And a string in double quotes right in the program is a string literal. We can also have integer literals like 4. We can have floating point literals, float literals, double literals. They're actually double literals for the most part, which are things like 3.14, just right in the program. And we can actually there's really no reason to store 3 in a long because it's small. That will work because an int can fit in a long. However, if we had something like it has to be bigger than, let's say, 3 billion. So So 3 billion cannot fit in an integer. A number directly in Java code that does not have a fractional component is an integer. It's an integer literal. In order to make it a long literal, we do something like that. And that says this is a long int. So that becomes a long literal. Yes, a long literal. And so we can store it in a variable type long. Similarly, we'll say double pi equals 3.14. That'll work fine because things with a fractional component are double literals. However, if we want to, for whatever reason, store it in the float, we can't do that because fractional numbers with fractional components that are literals are automatically double literals, and it's saying a double can store bigger numbers or more precise numbers is really what it is, than a float can. So we have to do something special here. That's that. That's a good question. I don't actually know the answer. The convention is that the F is lowercase. The L is uppercase. Looks like, as far as Dr. Java is concerned, it doesn't make a difference. A possible reason for that is that a lowercase L looks remarkably like a 1. Most of the time you won't ever deal with this stuff. The book may not even mention this.
So if you look at the L up and it says long, it's still defined as integer?
So the error was not that. So the number 3 billion can fit in a long, but when Java compiles this, it tries to squeeze it into an int because it's a literal value.
So if it was a smaller number, you would let the L up and then define it.
If I define it as a small number, it would that would be an int. It fits in an int, and it would just store it in a long. So it wouldn't break. There's nothing wrong with storing a small value in a type that is bigger than it needs to be. Right. Jill.
If you define it as a long, why does it consider it an integer or an int?
So when Java compiles, it turns these literals into, it has to give them some type. So it can't just, right now they're strings. We typed a bunch of strings into a text document, but it has to turn them into some numeric representation in order to compile it into Java bytecode.
So it's throwing it long.
Yes,
Because you put the word long.
because I put the word long there. Yep. Even with the anti-L, yes. Basically what happens is, later in the chapter, it talks about typecasting and probably mentions implicit typecasting. That's basically what's happening here. It sees an int and sees that it's being stored in a long, and since it knows how to convert an int into a long, it just gives it more space. It implicitly turns the int into a long. Yes. So on page 66, it talks about implicit typecasting. On the other hand, going the other direction, because a long can potentially store larger numbers than can fit in an int, if we want to store a long value in an integer, k, long integer. This will complain, because we're trying to fit a long into an integer. Longs can potentially store larger numbers than integers can, so Java says, are you sure you want to do that? And the way to say, yes, I'm sure I want to do that, is through an explicit typecast. And explicit typecasts are done by putting the destination type in parentheses before the value. So in this case, I want to take a long integer and I want to turn it into an int. So I put int in parentheses before a long integer. And now it will compile. That doesn't mean it will run fine. That just means it will compile. It is possible to get yourself in a situation where it won't run fine if you're actually using that extra space in a long. So if you store 3 billion, let's turn this back into 3 billion, make it a long literal, and at this point let's Let's remember some T's. We'll just print that out. I don't really care about this stuff, so I'm just going to comment it out. Right, comments. I mentioned comments last class. I mentioned that they go at the top of your programs and very specific comment block to use. Java has 3 types of comments, which are comments get discarded by the compiler. The compiler completely ignores them. So you can have source code in them, like I do, and the compiler won't care. It ignores everything that's inside a comment. Java has 3 types. The first type is this type, which is, I'm going to get these backwards. One is C type and one is C++ type. I want to say this is C++ type. I don't know why they're called that. Both C and C++ have the same types of comments. These comments work by causing the compiler to ignore everything, basically the rest of the line. So I can have source code, and then 2 slashes, and then everything else after that will be completely ignored by the compiler. The other type of comments have a slash followed by an asterisk, and end with an asterisk followed by a slash, like the comment block that's in the syllabus. That comments out everything that's between those 2 pairs of characters. Doesn't matter if there's source code, if there's just English writing. Doesn't matter if you start the lines in between with the star. That's another convention just to indicate, hey, I'm still inside a comment here. And then there's a special variation of that type of comment called Javadoc Comments, which starts with a slash and then 2 asterisks. And the only significance of those types of comments is that the program Javadoc, which is used to generate the Java API documentation, and you can use it to generate documentation for your own programs, looks for those specific comments to get its information from. But other than that, they're exactly the same as the longer comments that comment out everything in between the slash, asterisk, and asterisk slash. So we'll compile this, run this, and that is definitely not 3 billion. So when you cast a long to an int, the results are undefined for numbers larger than that, those that can fit inside an int. So if the number is small enough to fit inside an int, the conversion will work fine. 3 as a long will end up being 3 as an integer. 3 billion as a long will end up being whatever that is. Java identifiers follow very specific rules. They can have capital and lowercase letters, numbers as long as they are not the first letter, not the first character in the identifier, underscores, and $signs. I don't think this book mentions $signs because that's a very special case.
That's all we think about it. It's a special thing.
Yes, it's a footnote. Java does allow the $sign to appear in an identifier, treating it as a letter. But such identifiers have a special meaning. It is intended to identify code generated by a machine, so you should not use the $sign symbol in your identifiers. Yes, don't use the $sign. We will. We'll see it later. The short answer is there are two short answers. Two different short answers. The first answer is when Java compiles your program, it breaks complex statements. So 3 plus 2 minus 5 times 7, it breaks that up into smaller pieces. Closer to something that would, closer to what would run on a machine. So individual, someone's redecorating. Individual operations. And in between, it has to save those values somewhere. So it uses made-up variables that have a dollar sign in them. It uses the dollar sign basically to enforce that any variable the compiler creates will not conflict with a variable that is created by you.
So it like assigns temporary variables to the dollar sign?
Not just the dollar sign, but it's a full identifier, and the dollar sign is somewhere in there. The other place that dollar signs are used is in something called nested classes. When we talk about defining classes and objects, you can actually define classes within a class definition, and when Java compiles those, the name of that inner class ends up being a concatenation of the name of the outer class, the name of the inner class, with a dollar sign in between. Questions on variables? So expressions are basically sequences of variables with some operations in between them. Operations include things like plus, minus, multiply, and divide. Java also has a remainder operator, which takes the form of the percent sign. If you're familiar with the modulus operation, that will not help you in Java. The modulus operation is frequently symbolized by the percent sign. Java's percent sign operator is a remainder operator. So with the true modulus, you can't get a negative value. With remainder, you can get a negative value. And in that sense, so it's a remainder operator. Instead of dividing two numbers, so it's 3 divided by 2, Java's division uses integer division. So 3 divided by 2 is 1. It just drops the remainder. 3 remainder operator 2 is 1, because that, yes.
So when you want to get an accurate number, you have to put in both of those functions.
So to get around that, there are multiple approaches. If you're dividing the conversion between Fahrenheit and Celsius is a good example. In that conversion, you might want to put the fraction 9/5 into code. 9 divided by 5 is 1. Whereas when we're dividing it, it should end up being 1.8. In order to make 9 divided by 5 become 1.8, at least one of those values needs to be either a double or a float. The easiest way to do that is, say, 9.0 divided by 5.0. They're both doubles. The result of that division will be 1.8. Java assumes if you're dividing integers that you want the result to be an integer, which might seem kind of weird on the surface, but it turns out it's not a bad assumption. However, if you're dividing variables, integer variables, so a variable called 9 divided by a variable called 5, and they're both integers, you have to cast one of them, at least one of them, to a double. Then do the division. So we'll say So that will print 1. That will print 1.8. And that will print 1.8.
When you put the double 9 is that just that one on the code? It doesn't redefine 9.
It does not redefine
It
9.
just uses
No.
it in that
Correct.
formula as well.
Mm-hmm.
So we went to 9.0, 5.0, 9, was it the double?
They are double literals. So it treats them as doubles and divides them as doubles. And frequently we end up using multiple operators in a string of a big long expression. Java follows normal order of operations. In addition to parentheses, multiplication, division, addition, subtraction, there are several other operators that fit in there somewhere. So things like a function call or a method call, that gets evaluated first before anything else. Basically, Java needs to get values of some type so that it can perform all these operations on them. So that has to happen first. Parentheses, as normal, overrides normal order of operations. Parentheses get evaluated first. Typecasts get evaluated before the rest of the expression as well, because Java needs to determine not only the value of each of the components of this expression, but also the type of them, so it knows what to actually do. So this turns 9 into a double, the value 9 into a double, then divides it by the value that's in 5. And this is, so you could consider variable evaluation as an operation in itself that obviously has to happen first before any other operations can take place. So it has to turn double 9 into an actual value, the value 9.0. And it has to turn 5 into an actual value as well, the value 5.0. Then it can do math on them. So it's not actually doing math on the variables, it's doing math on the values stored in the variables. And that's why it doesn't redefine either 9 or 5. Questions about that?
In reality, you can just define the stuff in the first place and take away all the extra stuff, though. Like, instead of it's 9, you can do double 9, and it equals 9.0.
Right. In this particular case, since I know I'm eventually going to be dividing 9 by 5, I would probably end up doing something like what would this be? This would be C to F. And be done with it. And then I would take, say, double F equals scaling factor. This is why I don't use long variable names. Right, and that should hopefully give me the right answer.
If you had said double scaling factor C to F equals 9 divided by 5, it would still be better way. Like you don't need the 0.0, or you need the 0.0 in order to make sure.
If I did that, that's what you're asking?
Yeah.
That would still do integer division. 9 is an integer divided by 5 is an integer, and give me 1. Yes, because it's
Because it treats 9 and 5 as an integer.
right. You have to look at how Java is evaluating everything. And in this statement, Java starts by evaluating the value 9. Okay, it's already a value, don't have to do anything there. The value 5, it's a value, don't have to do anything there. Then the division, 9 divided by 5. Hasn't looked at anything else in the line. 9 divided by 5 is 1, because it's two integers. Then it says, oh, I'm storing this in a variable called scaling factor C to F, and it's a double. Let me create a double in memory and put this value 1 that I've just computed into it.
So, but only one of them has to be a double. Like you could do 9.0 divided by 5.
Correct.
You have to do both.
Just at least one of them needs to be a double. I guess one way to say that is that Java treats the entire expression using the value, or the local expression using the value that has the highest precision. So if anything involved is a double, in that section of the expression uses a double.
So you could put in scaling factor C to F and 9.0 divided by 5 and it's something that is double.
If I had int instead of double right here,
Yeah.
it would, so 9.0 divided by 5, it would compute that as a double, and then it would try to cram it into an int. And at compile time, it would recognize that that's not something I should be able to do.
You can't go down the row unless you
Right. Unless I do a cast. Which would have the result of, even though 1.8 is larger than 1.5, it would still just drop the decimal, the fractional point part, and I'd still get 1.
So when you're doing doubles, make sure the class is double. So
Right, the type should be double, yes. And there's a nice graphic at the bottom of page 64, and at the top of page 64, actually, that shows the primitive types in order of increasing precision. So things starting at a type on the left side and going to a type on the right side, or following the arrows, you can use an implicit typecast and that will work fine. Going the other way, you need to specifically say, yes, I know this is going to potentially break, but I really do want to do this. Okay, in addition to arithmetic operators, plus, minus, divide, multiply, there's also a very important one that we've used. What's going on? Yeah, I know. Stop. Okay. Very important operator, the assignment operator. It's simply an equal sign. On the left-hand side of the equal sign, we have a variable name. On the right-hand side of the equal sign, we have a value, something that evaluates to a value. So it can be another variable, which simply copies the value from one variable to the other variable. You can have an expression, which computes some value and saves it in the variable on the left-hand side. It can be a method call. So the scanner keyboard line 32. For our purposes right now, we can pretend this is a method call. For all intents and purposes right now, it is a method call. Scanner keyboard is a variable of type scanner. Then we have the assignment operator on the right side. We have a method call to something called scanner and pass it an argument, system.in. in addition to the simple assignment operator, which is just the equal sign, we can also combine the arithmetic operators with the assignment operator. So if we wanted to, let's say 8, we can say equals 5 plus 3. Alternately, we can start out with 8 equaling 5, and then we can say 8 equals 8 plus 3. The variable names are kind of misleading because there is a point where 8 is not 8. It turns out that this construct is used so frequently that there's a shorthand for it. And that is to take out this part and put a plus sign there. 8 plus equals 3. Exactly equivalent to what I had there before. It just evaluates the variable, adds the number on the right hand side of the specialized assignment operator to it, and stores it back in itself. There's even more of a shorthand than that, because frequently when we're doing stuff like this, the thing we're adding to the variable is 1. This is known as an increment or a decrement. I'm running out of good names for things. G. Let's say we want to get the value in G down to 8 from 9. We can simply decrement it. So instead of doing G minus equals 1, we can do G minus minus. Equivalently, on this line, we can do minus minus G. There is a subtle difference between having the increment or decrement operator before or after the variable. And if you're not careful about that, it can get you into some... I've built contrived examples that demonstrate that weird things can happen if you put it on the wrong side of the variable. In general, it's a good idea to have an increment or decrement on a line by itself. And if you're not going to have it on a line by itself, don't use the variable more than once in the same statement, because that's when you get into trouble. The distinction between the prefix notation and the postfix notation, whether it's before or after the variable, is that when the variable is evaluated, the prefix notation increments or decrements the variable right before it's evaluated. So minus minus G would actually turn G into 8 and then evaluate. However, having the minus minus after the variable causes the variable to be evaluated first, and then after the variable's already been evaluated, then it does decrement. So
minus minus G would be 7.
So, what's a letter I haven't used yet? J. So, in this formulation, J will end up being 9. And I can actually... Nope. In this formulation, it will end up being 9. Let's do that. future values. Comment that out. So J is 9 because G is evaluated first and then decremented. So J gets the value that G was at the beginning of the statement. J gets 9. G after that statement has the value 8. However, if we do so don't do that. Don't leave code like this. That gives really weird yes, it does result in G being decremented twice, but if it's in the middle of a statement, it goes kind of wonky. Actually, that might be a compile error. I don't remember. I've never done that. You don't want to do that. So now with this formulation, G is decremented, and then it's evaluated. So G gets turned into 8, and then the value 8 is assigned to J. Most of the time, no, all of the time in this class when we use the increment and decrement operator, it will be in a situation where it doesn't matter whether it's prefix or postfix. Some people like using prefix. They like the way it reads. Some people like using postfix. I think the convention is generally to use postfix unless there's a good reason not to. Because, like I said, most of the time it's on a line by itself. So now we can move on to section 2.2. I mentioned that string. Yes.
When you assignment operators in the book, it says it goes to the right and matches it to the left. Is that why J equals 9? Because it goes to G, let the variable G first, then the decrement?
No. What the book is referring to is that it evaluates. So you take an assignment statement and split it in half on the equal sign. Java evaluates the right-hand side first, completely ignoring the left-hand side. So that's mainly that. If I have a double variable and I'm doing integer division, why doesn't it compute it as a double? That's why. Java splits it down the middle, takes the right-hand side first, deals with that, and then worries about the assignment step. So I mentioned that string is not a primitive type, even though for the most part we've been using it like one. There are string literals. This J equals, for instance, that's a string literal. Strings are technically a class type, but because strings are used so often, they get kind of special treatment. String literals are anything between double quotes, even if it's just a single character. And we can have variables of type string. Something like that. So a string, because it's not a primitive type, it is capitalized. But it is still a variable declaration. This variable's identifier is hello, its type is string, and its value is a string literal with the text hello exclamation point in it. And we can print that out. Like that. Let's get rid of some of this stuff. Here's the other form of comment. Prints out the string hello. Strings have an odd property that is unique to the string class. No other class type is like this. You can use what looks like the addition operator on strings. And this performs the function of concatenation, taking two things that are strings and smashing them together into one larger string. So for instance, we could do something like that. It also works with strings and things that are not strings, and Java will do its best to take whatever is not a string and turn it into one.
Does the concatenation operator add a space automatically?
No, concatenation does not add any spaces, doesn't add anything. It just takes the thing on the left side and the thing on the right side and smashes them together. So Python kind of does add a space in some ways. Java does not. So that's why I had to add the space after the hello. If I didn't add that there, it would be hello world, one word. Yes.
So you can just type in the hello world and add the
Yeah, so this is a syntax error. It sees two variables and doesn't know what to do with them.
Same if you have a comment, right?
Yes. That will not work either. Println can only take a single value between the parentheses. So whatever you put in there, even if it contains multiple variables, multiple different pieces, eventually Java needs to be able to take that and turn it into a single value. Preferably a string, though it does. Println can handle other data types. All of the primitive types, floats, doubles, ints, longs, etc. Yes? Compiler error. It says operator minus can't be applied. Same thing if you try to multiply two strings, divide two strings, take the modulus of two strings. The only thing you can do with strings, the only operator you can apply to strings is the plus operator. Even though things like the minus operator and potentially multiplication and division might make sense in certain contexts, and some languages do actually have definitions for that. Java does not. There are methods that allow you to do some of those things, but not operators. Other questions?
If you want to put like Unicode indexing statement,
Yes. Because there's no space at the beginning of the value of world. Some people, while working on the assignment, were doing things like this. And now that we've talked about operator precedence, this will not work. Because 4 is added to hello becomes a string. Hello space 4. Then trying to divide that by 3 doesn't make any sense. Dividing a string by an integer does not make sense.
So this is
Yes, operator precedence. There we go. That will not work. There we go. And operator minus can't be applied to strings. Division happens before plus, no matter what the plus sign is doing. Sorry.
that's okay.
Okay. The way to get around that is just add parentheses. In Java, classes have methods, and objects have methods. So strings have certain operations that can be done to them, or that you can do with them. Basically, methods. So, for instance, you can get the length of a string. That should give 6. The length of the string. H is the first, E is the second, and so on all the way up to the space. Finding the length of the string. If you get keyboard input, for instance, the assignment asks for get the entire next line, which could be an arbitrary length string. If you want to enforce that it be fewer than 30 characters or something like that, you can get the length. And we haven't gotten to decisions and conditions yet, but you could do something like that. There are several other methods on strings that are listed on page 86. So the Concat method, the third one in the box, is equivalent to the plus. It says that as well. You can use the plus operator instead of concat. It takes the object before the dot, which the book refers to as the receiving object or simply the receiver, concatenates the string that's passed into the method with it, and evaluates to the complete string. So in here I had hello plus world. I could instead do hello concat world. It would do the exact same thing. Does not affect either world or hello. You do. The period basically, one reason the period is there is to say the character before the period is the last character in the identifier, and the next character is the first character in a name of a method. The dot notation is pretty widely used among a lot of different programming languages to mean basically method ownership. This object has this method. This method is being called on this object. This object is the receiver of this method. And we'll talk in excruciating detail about that in a later chapter when we talk about creating objects and classes. Some other interesting methods are things like substrings. You can get a piece of the string by giving the starting index. Strings are 0 indexed, so the first character has index 0. So calling the substring method with a single argument of 0 returns the entire string. Yes. So let's do system dot out hello.substring. So that will print out the entirety of the hello string. And that will print out from the second L onward.
So will it say the hello and then the secondary hello?
So this line will print out hello world. This line will print out hello, the entire value of this string. And this will print out from then onward. So, if we run it. You can also specify an ending index. So if I just wanted to print out the that L, I could do something like that. Yeah.
So could you do substring 3 and 4 plus another substring?
Yes. So
Substring 2.
let's do world.substring so this should print out LOR. The reason for that is that each substring method evaluates to a string. They can then be concatenated together, which evaluates to a string. And there are a bunch of others. There are also times when we might want to put a let's say quotes in a string, but obviously that's not going to work because double quotes end the string. To get around this, we can precede it with a single backslash, and these are called escape sequences.
You need it in between double quotes, or
You need it before the character that you're escaping, so before the double quotes that are being escaped. And sometimes it can get confusing, but this begins my string. I don't want this to end my string. I want it to be part of the string, so I have to escape it. World is still part of the string. I don't want this to be ending the string. I want it to be part of the string, so I put a backslash in front of it, and then this one should terminate the string.
so if you put it the other way, we end in that first double quote at the end of it.
And be a syntax error. It does look slightly lopsided, but that's the way Java chose to do it. And obviously, because the characters in this string have changed, what I'm printing out, what I'm doing the substring, is different now. At the top of page 89, there's a list of some of the other ones. You can do single quotes. Since a backslash represents the escape sequence. In order to put a literal backslash in your string, you need to escape it. So 2 backslashes is a literal backslash in a string. There are also special characters that are termed non-printing characters. New lines, let's see. Character terms, new lines, and tabs. Putting a literal tab character in strings does not work very well, especially when lots of text editors automatically replace tab characters with 4 spaces or something like that. So \t is the preferred way to do it. New line does exactly that. It creates a new line. Carriage return does something slightly different, and the history of those 2 characters dates back to typewriters. So, has anyone here not used a typewriter that had a physical carriage? Really? Okay. So typewriters had keys, and then a physical carriage that contained little hammers with the typeface on it. As you move across the page, this carriage moves across, and at the end of the line, when you hit the return character, it was named the return character because the carriage would return back to the beginning of the line, or in theory, feed the paper and move back to the line so that you can start typing on the next line. Really, 2 operations are going on. The paper is advancing, which is the new line, and the carriage is returning to its starting position, which is the carriage return. When computers first came about, those 2 operations were turned into non-printing characters and became their own characters. Until Mac OS X came out, the 3 major operating systems were on 3 different sides of the fence with respect to what computers should use in text. Windows used a combination carriage return and new line. Unix used the new line all by itself, and Mac OS Classic went with the carriage return. Now, Windows still uses carriage return and line feed, or new line, and Unix, Linux, Mac OS X, every other operating system known to man uses just the new line character. So, in reality, system.out.println uses the line terminator that's appropriate for the system that it's on. If you need to put a new line in your Java program by itself, use just the new line character, and Java will figure out how to do the right thing. You can also use the carriage return character by itself. This has the effect of not doing the new line operation. So \n is basically carriage return and new line all in one. Carriage return just does the carriage return. It doesn't go to a new line. So it starts typing characters right over top of the other ones. Let's see if Dr. Java respects that.
So have to go, the escape cases have to go before, but that last double quote are going to go after.
This one?
Yeah.
Anything outside of this double quote is not part of the string,
Okay.
and will be interpreted. Java will try to make sense of it and probably fail. Okay, Dr. Java does not respect the carriage return character. If I were to use this on an actual terminal, it would demonstrate the desired behavior. Don't worry about navigating a terminal. You don't need to. That's not part of this class. So that's the desired behavior. That's what you have. So it overwrites those first 4 characters with oops. And you might recognize some of this from the end of the first chapter, because the author doesn't make any assumptions about Dr. Java or anything like that. So he presents the command line, how you do it from the command line, which, for reference, Java-C is the program, the Java compiler, which takes a source file as an argument and compiles it. And then Java without any trailing characters is the runtime, and takes the name of a class file without the .class on it and runs it. Let's see, what else? What else is in this chapter? I guess that's it for today. And perfect timing, because it's break time. We'll reconvene in 10 minutes, and then we'll I'll suggest some exercises from these first 2 sections that can give you some practice for how to deal with variables, expressions, and strings.